Hey everybody, this is David, opposing the Matrix. How are you? I've got this new thing there I'm using as a sound device here, and I just got to turn up my bass a little bit, and I think it makes my voice sound better. So I'm going to go with that, and we're going to turn down the highs a little bit. Yeah, that's better. Oh yeah, okay. Okay, we'll go with that and see how it is. If anybody thinks it's funky, write to me. If not, then I'll know it's okay. All right? Hold on, folks. When you got no feeling in three of your fingers and you're trying to put one of these in, it's not easy. Okay. All right. Here we go. All right. So welcome. This is Opposing the Matrix. I'm back from the dead. Really, folks, it felt like it was going to go that way. Oh man, I'll tell you. So, yep. I'm on prednisone now, and that's helping out a lot. And another medication that's helped me out a lot. And so I finally got to see a doctor that knew what she was doing. Okay. ER doctors are weird. Some of them are anyway. But yeah, when you have a serious infection in your sinus and a doctor sends you home with I have a nebulizer, and we send you home with a mask with the nebulizer and tells you to use salt water solution to put in there and just breathe so it loosens things up. You know, there's a problem. Anyway, yeah, I'm on an antibiotic too. That's what it is. So a really good one too that I've really liked, and I can even remember when it came out back in the 90s. My goodness, I'm getting old. Okay. So Opposing the Matrix again. We're coming to you from well, today, wonderful, chilly, but beautifully windy Oregon. I had to think about that for a minute. It's not something to brag about. Okay, Oregon is a beautiful state, but boy, some of the people that live here, I'm telling you, you wonder sometimes. Okay, anyway, I had a lot of time to think the last couple of weeks, and I had an opportunity to read a lot about things that are going on and everything. And one of the articles that really caught my attention, and really caught my attention, and it blew my mind, and it still does to some degree, is that Google has been messing around with quantum computers, and they got every right to do that. I think it's kind of cool, actually. But quantum computers are different. We're going to find out exactly today what they are, what they do, and what's so concerning about them. Okay. I had a chat with ChatGPT today, a chat with Chat. And in that chat, I was trying to find out if there were any evil nuances about this quantum stuff. And boy, I'm telling you, the guys that write the algorithm for ChatGPT must really like this quantum stuff, because I almost got yelled at by this ChatGPT, this artificial intelligence. I mean, if you can get yelled at by something that doesn't have a personality and doesn't know how to have emotions, that's a skillful thing that ChatGPT does. And it's kind of strange, and it's kind of, I don't know, they always say that these things aren't going to have sentience, but when a artificial search or artificial intelligence becomes a smartass, there's something going on there. Hold on, folks, I got to get a drink here. I ran out of Pepsi Zero. I'm going to drink an iced tea. I guess that's a better choice anyway. Anyway, you know what I started doing this week? I started listening to Michael Savage again. I just fell away from him, man. I got so much to do, and then the other day I was thinking, I remember the intro into his show. It's the Savage Nation with your host, Michael Savage. And I'm like, wow, that's kind of cool. I'll listen to him, and I've always considered, if I was to compare myself to any person, secular or even believer online, I would put myself more like him than anything else. I think he gets away with a lot more than he than I do, but and that's okay. But I've got I've got family I have to answer to, and they listen to the show, and they or they watch it rather. And if I get a little spicy sometimes, it's like, you know what, you're a believer. Should you really be saying stuff like that? And I'm like, well, yeah, you're right, I guess. But man, I was ticked. I had to say something. And that's usually, that's the end of it, and we go back to our normal lives. But yeah, so Michael's been kind of cool all these years, and I've really enjoyed listening to him, and I've identified with a lot of the things that he says. Although he does go off the deep end every once in a while, but I guess I do too, huh? So anyway, let's get to the crux here. The crux. Do you know crux means cross? Did you know? In Spanish, Las Cruces, New Mexico means the crosses. I never knew that until about, I guess it's been 20 years now. But yeah, I thought it was kind of interesting. I'm finding out that Spanish is a lot more like English than I ever imagined that it was. But anyway, so disclaimer real quick before we go into this. I still have vestiges of that cold that I had or have, or in Yeshua's name I don't have it anymore, okay? But it's some of the side effects are still trying to hang on. But yeah, just a little in the nose and in the throat. So I might, when there's videos playing, we're going to watch 3 videos today, at least. I talk about what Google has done, what they found out, and hey, Rocco, come here. I got to introduce you. I know you've met him before. Come here, Rock. Come here. This is my dog, Rocco. Come on. Come on up. Come on. Every other time in the whole universe. Come on up. Up, Rocco. Up. There he is. This is Rocco. He's a Labradoodle. He's a good boy. And today he's my co-host, okay? So if you hear some noise in the background, it's Rocco making that noise. Okay, Rocco, say hi to everybody, huh? I know you're not going to say anything. You can make a liar out of me. Good-looking dog, too, and very heavy. Sleeps with us at night. He's probably close to about 100 pounds. And he's one tough. He's mellow a lot of times, but I noticed that I've been out here sometimes, and my wife will come out to say something to me, and if he's standing out here and he sees her, he growls, and that's my wife. But so I think he loves me, and I know he would protect me if he ever had to. So it's a win-win situation. But when it comes to family members, he's got to chill out. Okay, pardon me. Okay, so where am I going with this today? So yeah, Google. They're getting into, what do you call it, quantum computing. And there's a chip that has these things on it. They're called qubits. Now, when I read about them online, whoever wrote the article wrote it just like the unit of measurement that was used in the scripture, the cubit. The cubit was measured from the tip of the finger to the elbow. And it usually was 18 inches, and mine's 18 inches, believe it or not. And then the other measurement that was half of that was the span, and that's from here to here. And guess what mine is? 9 inches, half of 18. So, Yahweh plans things out, and he knows what stock I'm from, so he's going to make me look like that stock, I guess. I don't know, or measure like it anyway. And believe me, it helps. When you're out somewhere and you don't have a tape measure, it's not going to give you 1/16 of an inch or even half an inch, but I could tell pretty close to what something is if I stick my hand down and measure it to my tip of my elbow, or use the span. 9 and 18. 26. Okay. Anyway, so we're going to talk about, what I'm talking about today is quantum computing and Google's revelation. Okay. And I know that other companies are using this stuff and this thing, and what it is a computer chip that doesn't use bytes like ours does. This computer right here I'm doing this on, it uses bytes. And what a byte is, pardon me, is a system. It's a system of memory, and it's also a system of reading that computers do. And it's a series of zeros and ones. Okay, don't ask me how. I don't know. I remember that song "Hair" from back in the '60s. Don't ask him why, because he don't know. Anyway, so, and that's how a computer reads and how it stores memory. Okay, zeros and ones, which is kind of interesting to begin with anyway. But quantum computers, they use qubits. And a qubit can use the number 1 and a 0 at the same time. They said until it's counted. I don't know. This is all new to me, and I'm sure it's new to you too. There's probably 1 or 2 of you, maybe 3, that know all about this, and you're going, oh, well, I know all about this. See you later. But, you don't know what some of the implications might be. You don't know. We'll see. But don't leave. Stick around, okay? Man. Anyway, so let's see. Today we're gonna do stuff like define what quantum computing as a revolution. Define quantum computing as a revolutionary shift from classical computing, routed in the principles of quantum mechanics rather than binary logic. If that sounds like Greek to you, it sounds like it to me too. Okay, but this all has to do with quantum physics and stuff like that, as opposed to regular physics, the laws of thermodynamics and stuff like that. Well, that's just regular physics. But anyway, we can go into that in another show, actually, and look at the differences. I think that'd be pretty awesome, actually. So anyway, classical computers use bits, or bits. That was bytes. Anyway, bits and bytes. Bits and bytes got the computer technician fat. Okay. And again, bits are zeros and ones, but quantum computers use qubits, which can exist in multiple states simultaneously. Okay. Let me go into this real quick. I was, again, talking with, I never finished that story, with ChatGPT about this, because everything about this quantum computing smells dangerous, okay? I mean, when I look at it, I see a poison gas cloud developing that's going to just take over the earth. ChatGPT, though, did nothing but defend quantum physics, okay? I mean quantum computing. It asked it all kinds of questions. Do you think it could lead to this, or is it possible? You can't ask it if it thinks it will. Go into this diatribe about, I'm not human, I can't think, I'm not sentient, and it was really giving me a hard time today. It was really kind of ticking me off. Come on, folks. I made the mistake of eating popcorn before the show, and my goodness. Okay. So, so anyway, I was talking to it, or writing back. Actually, I was talking to it back and forth. And it made me sound like an idiot. It really did, because I was asking it about the conspiratorial stuff, that, if it could be true, if it could possibly become that, even though it's not that way now. And Chat got indignant with me. And basically, it said in the nicest terms possible, you're an idiot for believing that it could be anything else but a physical computer, if you believe that it goes to other dimensions, although it says it right there, other dimensions, and it explained it in some, a computer different dimension, not excuse me. But, anyway, it was being very difficult, and it made me sound like I was a moron, or at least at the very best a conspiratorialist, and that being conspiratorialists are all crazy. I must be crazy too. Okay. Well, I think everybody's crazy a little bit, but it was making me sound excessive. So So I kind of gave up talking to it. I mean, if later on, if we have time, which I don't think we'll have, I can go into the conversation that I had with it, and it was getting me kind of mad. So anyway, so let's see. It's interesting, though, qubits, it says, which can exist in multiple states simultaneously. Okay, meaning that it can use zeros and ones in multiple forms. When we see the videos tonight, you're going to hear the term until they're counted. I don't know. Let's see. So let's see. Let's look at the foundations of all this quantum computing, okay? Without getting too deep in this stuff. I feel like a drone now, noise out here. No, it's not. I don't mean the drone in the sky. I mean, think of an engine or something, or of a fan in a computer. Anyway, so Richard, last name is spelled Feynman, Feynman, 1982, proposed that classical computers cannot efficiently simulate quantum symptoms. And David Deutsch later formalized the concept of a universal quantum computer. Okay, it's a kind of very fast history of when it started. So we can determine basically, or come to the conclusion that 1982 is probably the birth date or birth year of at least the idea of a quantum computer. Remember back in the 80s, we all thought that and it still may be true, that the computer was going to be, or have something to do with Antichrist, because when you take English and convert the letters into numbers and spell computer, it comes out 666, and yeah, we all did that back in the 80s. I mean, Kissinger 666. Well, that was pretty close, actually. But anyway, let's move on here. So let's see. There's something in this realm that's called superposition. Okay, a qubit can represent both 0 and 1 at the same time until measured. There it is, until measured. I knew I researched that and wrote that down. Okay, let's see. Problems like factoring massive numbers, which secure modern encryption, can be solved dramatically faster than with a regular bit computer. Okay. So let's see. Modern moment. Google has recently announced a breakthrough, particularly in error correcting and scalability, that may move quantum computing closer to practical use. With any new system, it's going to have errors, especially when you're getting into something that's looking supposedly at other dimensions, and is doing such a large and laborious job. It's and since it's programmed by humans who are error prone, it's possible that it could produce errors, right? And if you don't think so, then how long have you been using Windows or your computer? And then you get to that final point where you've written everything you want to write, and all of a sudden that blue screen pops up, and it's a blue screen of death, and you've lost everything because you didn't save it right when you should have. I mean, the minute you took that last key, hit that last key, you should hit the save button. But no, you didn't do that, and believe me, I've done it many times. And I'm a fanatic about saving stuff now. I write a paragraph, save. Actually, I have it on autosave. Okay, scalability. Okay, so we're moving from theory to technology that could reshape reality as we know it. Now remember that, reshape reality. Okay. Actually, the reality that we live in is not a reality, right? Because we live in a matrix. So if how can it pervert or change a reality that's not a reality? Yeah, I'm just playing with words. You know what I'm talking about. It would be nice. What it would do is if it would bring us out of the matrix and into the real thing. But that's something that Yahweh instituted, and we're going to be in the matrix until He decides that we don't need to be in it anymore. And I think most of us grew up in it so much that we're so used to the matrix. It's anything else that we would have to live in would be very new to us and very hard to accept. although it's going to happen someday, so prepare. And we're probably not going to see it until after we come back with him, after the 7 years of woe and sadness that happen upon this earth, called the tribulation period. Okay, so we're moving again from theory to a technology that could reshape reality as we know it. Remember that scripture I'm always talking about? It's in chapter 10, I think, of Revelation, where the angel says, behold, time will be no more. Well, this might have a lot to do with it. Or maybe it could explain it a lot easier. That's a possibility. Okay. So let's see. Quantum computer basics. Let's look at these, okay? So let's explain the qubit. The definition, okay? Unlike a simple switch, a qubit behaves more like a sphere of possibilities rather than a fixed state. That's heavy, isn't it? A sphere of possibilities. Now, you flat earthers might start saying, well, maybe it's not a sphere, maybe it's a flat, a flat of possibilities. It's I don't know. Who knows? Okay, Yahweh knows, and Scripture shows. Okay. So then we have another thing called superposition. It's where multiple states exist simultaneously. We've all talked about that. We've all talked about that, or I have. Entanglement is defined as qubits become linked. Okay, this is trippy. Okay, qubits become linked. Changes in one instantly affect another, regardless of distance. This entanglement thing in quantum physics is real interesting because it was presented to me like an atom on that side of the universe, right? That side of the universe. Pardon me. I hate popcorn husk. Let's just, okay, entertain me, okay? I know atoms are very small. Let's say molecule. Maybe that's a better thing. It does say particle. It doesn't say atomic particle. Let's say it gets nudged. Okay, something comes by and hits it. That there is the possibility, strong possibility, that there's another molecule that's just like it on the other side of the universe that will know that one got hit. Is that trippy? And it'll know it instantaneously. Okay, it kind of makes you think of the mind, Now, if we were to take a trip to Mars, right? If we became friends with Elon Musk, hey, Elon, can we go to Mars with you? Yeah, sure. When we got to Mars, if we sent a message back to Earth, it would take a few minutes to get here. Okay, back to Earth. And likewise, sending a message back to Mars would take a few more minutes. So, but let's just say that our minds were linked or entangled, okay, with our loved ones, and we wanted to talk to them. The possibility that would exist then that whatever you thought and you wanted to transfer to your loved one would go to them instantaneously. Okay, instead of having to travel as radio waves all the way from Mars. Ooh, that's kind of trippy, isn't it? From Mars to the Earth, or from Earth to Mars. So that's the way I look at it. The entanglement thing, and you can see there's some. Yahweh gave us some examples. For example, look at twins and triplets. Okay, a twin can get hurt in an accident, or a triplet, and in the case of twins, I'm talking about identical twins now, okay? Two children that were born from the same, so I say yolk sac, and there was no, they didn't derive from separate ovum being fertilized. It was one ovum being fertilized that became two children because two of the seeds got in there. Every time I talk like this, I think about That's it. YouTube asking, when you do a video, is this made for children? No, it's not made for children. And that reminds me of some movies that I've seen that are hilarious, where the guy's trying to talk about that kind of stuff, but he can't because there's two little kids that came with their father to the conference. So, hilarious. Okay, let's see. So what's the key concept of quantum parallelism? Say that one 5 times fast. A quantum system that can produce vast combinations of possibilities at once. Okay. I think it's when you put quantum in front of it, just think of more than normal, more than common. Okay. I'm going to start doing that and see how that works out. So let's see. I'll read it again. A quantum system can produce vast combinations of possibilities at once. This creates exponential computational power compared to classic systems or classic computers. And when you think about it, that's I don't know. Sometimes you ever get the feeling sometimes mankind is getting so far technologically that we're kind of losing our humanity, that maybe things should have stopped at one level and not gone any higher. I don't know. I do. I feel that way, but sometimes it's because if it hasn't stopped yet when you thought it should have stopped, and maybe the guy next to you went up a couple levels, and that's when he thought it was supposed to stop. And some people don't think it's supposed to stop, and I don't know. It's weird because you start wondering, had it stopped, what would the state of the world be in? It's as aside from knowing that we live in a matrix now, and that the dreck that this world is just made out of and is experiencing in a whole 9 yards. So let's look at historical development. We'll go a little deeper into the history of this, okay? So again, in the 1980s, theoretical foundations were written by 2 different people. Again, it was Feynman and Deutsch. Okay, in the 1990s, algorithm breakthroughs. Peter Shor, spelled S-H-O-R, in 1994, demonstrated that quantum computers could factor numbers exponentially faster than classical computers. And in the early 2000s, experimental hardware begins to emerge. Yeah, because the theory is great, but if you don't have something to work it out with, work it out in, then you're kind of up the river without a paddle, right? So major achievements so far: quantum supremacy milestone. In 2019, Google claimed quantum supremacy. Their quantum processor solved a problem in minutes that it would have taken classical computers thousands of years. Okay. Implications of quantum algorithms. And there's more that's listed here, but we'll just, you can only write so much, especially the time I had to get ready for this show was amazing. It's just this well or far done. I'll say well done too. Implications of quantum algorithms. Shor's algorithm could break wildly used encryption. Oh, so let me start here. Shor's algorithm could break widely used encryption systems like RSA. I'm sorry, I didn't have time to look at what RSA is, but it's a method of encrypting very powerful and secret information. This has triggered global efforts to develop post-quantum encryption. You see, every time something is made like this, you have to build safeguards in case the thing goes wacko, And I don't know, it's pull the plug, I thought it should be the it'd be neat. Quantum computation, pull the plug. Excellent T-shirt. So emerging applications for this, okay. Drug discovery through molecular simulation. Maybe that's how they got all the the information of how to cook up the quick. You know, I'm going to have to carry around one of those with me to kind of show you what I'm talking about. But think about getting a needle in your arm. Okay. Let's see. Drug discovery through molecular simulation. Optimization problems like logistics, supply chains, advanced material designs. Okay, there's just 3 of them where there's been emerging applications, and as long as there's things to fix and things to figure out, they're going to find a way to do it with quantum computers, just like they have with classical computers like we use right now. Google's recent revelation. Oh, here we go. You ready? Google has made progress in one of quantum computing's biggest challenges, error correction. So why this matters? Well, quantum systems are extremely fragile and small. And small disturbances, cause errors. That reminds me of playing Jenga or something, and you're building something or tearing something apart real carefully, and somebody comes in and hits the table and it all comes down. So maybe when you think of quantum computing, think of Jenga. Okay. So Google's breakthrough, improved error correcting methods, and the ability to scale qubits while reducing errors. Okay. This moved quantum computing closer to practical real world use rather than experimental demonstrations. So what's the big picture here? This isn't just a faster computer. It's fundamentally a new way of processing reality at the quantum level. I want so bad to say something. We'll see it later. Future potential and expectations. Near term, okay, meaning close by. Quantum advantage, solving real-world problems faster than classical computers, like logistics optimization, financial modeling, material science, or sending answers back that haven't been... This is one of the things that it has done. Okay, I put this in there. Well, I put it all in there, but this was what I just put in before the show. Sending answers back that haven't been asked yet. It's freaky. Okay, so what are some of the long-term possibilities? Okay, drug discovery through precise molecular simulation. Another one, creation of entirely new industries. Yeah, it's kind of hard to wonder what that would be, right? I don't know. Maybe they're finally going to find a practical use for left-handed monkey wrenches. Okay, let's see. Economic transformation driven by computational breakthroughs. Okay. I mean, computers have been doing that forever, but I guess it's going to be on a larger scale, or what they're expecting anyway. Who knows? The whole thing could go crash and burn in a year, but the way it's going, it looks like it's going to be a reality. Speculative horizons, quantum societies. Think about that. Using quantum simulations to model entire economies or complex systems, like 15-minute cities. Okay, accelerated innovative cycles across science and technology. So what about ethical and speculative concerns? Okay, let's start seeing maybe what some concerns can be and why we won't want this. Okay, security risk. Quantum decryption could break current encryption systems, threatening global cybersecurity. That's pretty serious. Imagine one day the Pentagon finding out that everything they've written for the last year has been copied and decoded and on sale to the first customer that gives a price that sounds reasonable. Let's see. Governments and organizations are already working on post-quantum cryptography. That's interesting. Cryptography is basically how you how you make these things so that they can't be broken into using cryptic passwords and stuff like that. Okay, what about governance and control? Discussions are beginning worldwide about regulation and oversight of quantum technology. You know what? I don't like government oversight, but this might be one that's would be worthwhile, unless it would be one where the government would be bought off by these quantum companies, and it would be even worse, right? Okay, what else? Speculative questions. What about sentience? All right. I've always believed that in the future, and I've always believed this, even when I didn't know much about computers back in the 80s and stuff, that in the future, computers would become so powerful, so strong, and so intelligent, let's put it that way, that they would be able to make their own next generation of computers, and that would go on and on and on, okay? And that sooner or later, the creation aspect of what they were doing would, they'd sit here and realize, you know what we've been doing is the same thing that God did. Granted, he started from dust to make humans, right? From the mud or dirt or clay, as the scripture said. And so, but computers don't know what for. They don't know. They know of God, but they don't know Him. Well, a lot of people don't either. But the rest of us that are born again, we hopefully I have a wonderful relationship with Him. Hope you do too. So, but I think there could be a time when a computer could cross that barrier. I mean, for all of our lives, they've been telling us that without any proof, that species can jump evolutionary-wise to next species, okay? In other words, dinosaurs became birds. Boy, that's a frightening aspect, isn't it? Imagine a T-Rex with wings. Oh, my goodness. Maybe that's what those small hands developed. I don't know. I was watching a video the other day, and they scared this lady. They were telling that she was they call it the raptor scare. It was pretty funny. So let's look at this. Sentience. Could advanced quantum-based AI ever become self-aware? So while highly speculative, it raises philosophical and ethical questions worth considering. What's the core concern? Like any powerful tool, quantum computing can be used for good or harm. Man's done that since he learned how to light a fire, Actually, I gotta recant that because that makes it look like we were cavemen and we weren't. Adam was born with a fairly good and super intelligence like we have today. Probably even more intelligent than we are today. I think a lot of past generations were. Okay. So while highly speculative, it raises philosophical and ethical questions worth considering. And again, like any powerful tool, quantum computing can be used for good or harm. Atomic energy, okay, well, it was first used for harm, and then it was used for good, because that was kind of backwards, that happening, And, but you look at anything, fire. Well, let's go back and look at fire. It's been a tool of mankind's forever. And mankind has used it in good ways to heat himself, to cook his food, to heat himself and his family, to cook his food. What else do we use heat for? A majority of different things, right? Heat swimming pools, the whole 9 yards. But it can also be used for bad. I mean, it can create a flamethrower that could turn other soldiers into crispy critters. We found that out in World War II, right? We saw it. The Japanese found it out. Yeah, that's a terrible way, isn't it? A terrible way to go. But they had to be innovative back in World War II because the Japanese were not going to give up for anything. So they were kind of their own worst enemies. We were their enemies, but they were our own worst enemies. Okay, let's see. So let's see. This should bring an emphasis on an emphasis up of human oversight. Okay, right now, getting down some legislation that would keep people from doing stupid things with this technology, with quantum computing. I mean, and you want to talk about, you could write laws, you could probably put a new law into effect every day regarding quantum computing and do it for 5 years without stopping. Okay? It's just, there's so many possibilities that quantum computing could be involved in. Good, of course, like we talked about, but also very evil. Okay? And if this thing is able to look, these things, excuse me, with the qubits, are able to give us answers to questions we haven't even asked yet. Man, that blows my mind. I asked, when I heard that today, I my wife, and I said, the lottery numbers. Okay. So let's, in conclusion, so technologies like the internet brought both transformation and unintended consequences, right? Oh man, the internet, what a mess. You know, never before in history have people been able to pick fights with other people without even seeing them. Ruin people with, fake news, for goodness sake. I'm following this Iran thing, and I have to, every time I turn on YouTube to look at things concerning Iran, what's happening over there, the revolution and the Americans and Israelis attacking, and the Houthis down in Yemen and everything else that's going on. I would say 2 out of 12 stories is true. And the other ones, they always seem, I don't know, to me anyway, they seem to give themselves away. And, it'll say like nighttime attack in Iran. And then the first sentence says, at noon in Iran, this attack. And I'm like, okay, well, it can't be nighttime if it's noon. So then you read a little more and you see that it's all garbage. Pardon me. So let's see. Yeah, so anyway, unintended consequences. Well, with that stuff, it's intended. It's propaganda to try to ruin our war effort and stuff like that. And I don't know. I think that the Iranian people deserve to be free. They really do. They've suffered under that mullah system for the last 47 years. Isn't it funny? It's been 47 years. Trump's the 47th president. I don't know. That number's been coming up a lot lately. It's kind of weird the way it has. Recap the balance. Okay, quantum computing holds incredible promise too, but it also carries profound responsibility. And that's why I say, they need to be getting in the halls of Congress and in the state legislatures. They need to start working out things to where it can't happen. Okay? That nefarious things cannot happen because there's already a law against it. And the minute you try to start anything like that, I mean, there's common sense, there's fraud. So if you try to commit fraud with quantum computing, you've already got that covered. There might be some little extra special nuances you want to add to the law, but there are weird things. What about speculation? Rules against speculation, because this thing is supposedly going to different dimensions, although ChatGPT says they're not real dimensions, in a physical sort of way, that they're, some kind of computing dimensions. I don't know. I don't know. It was weird how it was really sticking up for quantum computing. But anyway. All right, so let's see here. So we're stepping into a new computational reality. The question is not just what we can do, but what we should not do. Okay. Wait a minute. Okay. The question is not just what isn't not just what we can do, but what we should do. Okay. But also cannot do. Um, yeah. Yeah, that's interesting that they put it that way. I wonder who quoted that. Whose quote that was. I forgot. Um, not what we. The question is not just what we can do, but what we should do. Yeah. So, in other words, we need to be proactive, thinking about this stuff, thinking about all the things that could happen. The one thing I cited earlier. Maybe the people using it to break into the Pentagon system and stealing all the secrets that the Pentagon has. It's I wouldn't put that past the Chinese or the Russians in a minute. So how do we ensure this technology ultimately serves humanity? Well, that's a question that's going to have to be answered some other time because it's just it's a question that's kind of asked before its time. So I mean, this thing is just getting started off, and I don't know. I'm of the opinion that this quantum computing, a lot of the different things that are happening nowadays are going to be turned against us. Yuval Harari with his stop being a person and become part of a machine, or vice versa. I'm not too hip with that idea, and I explained why several times on this show. And Elon Musk with his little brain thing that he snakes up through a vein and implants in your brain that is supposed to help you with some maladies that people have. But that one could really be used against people, just about anybody. And if they stick, I want to put it that way. If they knock you out somehow, you have no say whether it happens or not because you're asleep, right? And or you're comatose for a little while while they're doing it. But anyway, so it's a clear and present danger that we really need to be careful of and constantly looking to see what's going on. That's why I like doing this show, but I also like watching things like as crazy as it is, Joe Rogan, and oh man, there's tons of them out there. But we have to choose wisely what we watch because this quantum computing is pretty tricky, and maybe it's out there making videos about how good it is and how mankind should use it and forsake all others, so to speak. Okay, folks, what I want to do now is there are a few videos. Let's see, how long have we been on the air? Now we're on the air, but it's only been 48 minutes, so I'd like to present to you a few videos. The first one's going to talk about the leak at Google, okay, and how that happened and everything, and why it's a concern. And the second one, I wanted to kind of talk about the second one real quick. In this video, the second video we're going to watch, you're going to talk a lot about things that kind of look to me or sounded to me like the whole yin-yang idea about how, what do they say? They say that there's no backwards or forwards, that both states are the same. I don't know about that. I mean, in practicality, it's not practical, but in reality, I mean, it's not practical. But they try to almost put like an Eastern mysticism air about it, about quantum computing. So watch out for that because some of the stuff is it's buried a little bit. I mean, they bring it out, but it goes pretty quick. But you'll see what I'm talking about. This whole evil is and good are both the same thing. I don't know. I guess that's how weird things happen in Asia, because that's a philosophy that's been rooted in Asian societies for thousands of years, from India all the way through China and into Japan. So anyway, when we do the second one, I'll warn you again, but watch out for that. And so let's see, I forgot the name of this one. Oh yeah, quantum Google quantum used math to predict the future. This is a really interesting video. So I'm gonna play it last, so you gotta stay till that one. But let's see here. I'll tell you how long each one's gonna be. Google linked is 14 minutes, almost 15. Google found universe that I was talking about, 18 minutes, and quantum, and the third one I was just talking about is 22 minutes. So they progress in length as we go along. So I'm going to be taking a little snack while we're watching the video. So I'm going to mute myself and hope to turn it back on. I'll figure out a way to do that here. As a matter of fact, you'll be my witness. Okay. Okay. Turn off muting. Okay, and I'm going to put that right in front of me where I can't miss it. Yeah. I can't, some of you young people are going, oh, man, this guy forgets a lot of stuff. Well, wait till you're in your late 60s, and we'll see if you're the same way. My problem is I've used my brain too much all these years. I never stopped to smell the roses. I don't know. I don't know. You get to my age and you start thinking, yeah, I could have done this different. I could have done that different. So, I don't know. So let's start this video stuff, and we'll go with that. And these are very interesting, and you gotta just watch them and absorb. And look for little keywords, look for little nuances that they talk about that kind of give it away. Okay, so I'll put you in that charge, and there's not going to be a test or anything at the end, but if you know that there's some stuff you really got to look for, you'll look for stuff, right? Okay, here we go. The original video about Google leaking something very very interesting. Here you go.
Google's latest breakthrough in quantum computing has stirred excitement and debate in both the scientific community and the public sphere. At the center of the discussion is Willow, the company's new quantum chip, which reportedly achieved a computational feat so complex that it would have taken today's most advanced supercomputers an estimated 10 septillion years to solve. Yet, Willow accomplished it in under 5 minutes. This unprecedented result has led some scientists, including Hartmut Neven, head of the Google quantum team, to suggest that the implications go far beyond technology. Neven has publicly expressed his belief that Willow's performance supports the idea that quantum computation might actually be occurring across many parallel universes, an idea drawn from the many worlds interpretation of quantum mechanics. This notion, while captivating, is not new. The concept of parallel universes has long fascinated physicists and philosophers alike. In particular, Oxford physicist David Deutsch was one of the first to propose that quantum computing could serve as indirect evidence for the multiverse theory. According to Deutsch, the massive computational power harnessed by quantum computers could be the result of their ability to access computational resources from parallel realities. This idea remained speculative for decades until recent advancements in quantum technology, like Google's Willow, reignited the debate. Quantum computing, unlike classical computing, operates on qubits, which can represent both 1 and 0 simultaneously due to a phenomenon known as superposition. This allows a quantum computer to process a vast number of possibilities all at once. When combined with another quantum principle, entanglement, where particles become interlinked and instantly affect each other regardless of distance, the computational power increases exponentially. This level of parallelism in processing is what fuels theories that quantum computations might occur across multiple versions of reality. Neven's remark that Willow's breakthrough lends credibility to the multiverse theory was met with both intrigue and criticism. Astrophysicist and science writer Ethan Siegel, for example, challenged the connection between quantum computing and parallel universes. He argued that Nevin conflated the mathematical structure of quantum mechanics, the Hilbert space, where wave functions reside, with the literal existence of other universes. According to Siegel, while quantum mechanics allows for probabilistic outcomes and complex computations, it does not necessarily imply the physical reality of multiple worlds. Despite this critique, Siegel acknowledged the magnitude of Google's achievement. Willow represents a massive step forward in computational power and could pave the way for revolutionary applications. From developing new medicines to designing highly efficient energy storage systems, quantum computing holds promise for transforming numerous industries. Scientists believe that problems currently deemed unsolvable due to their complexity might be tackled with future quantum processors. Willow is the successor to Sycamore, Google's previous quantum chip that made headlines in 2019 for achieving what the company described as quantum supremacy. Sycamore operated with 53 qubits and later reached 70, while Willow boasts 105 qubits. Each additional qubit dramatically increases computational capacity. This advancement was made possible by refining the architecture of the chip, reducing error rates, and improving qubit coherence times. The fundamental principle that allows quantum computers like Willow to perform so effectively lies in the strange and often non-intuitive behavior of quantum particles. The phrase spooky action at a distance, famously used by Albert Einstein to describe entanglement, becomes a practical reality in these machines. When qubits are entangled, the state of one instantaneously influences the state of another, regardless of distance. This creates a network of interrelated data points that can compute many possibilities simultaneously, unlike classical bits that must process one option at a time. For Nevin and other proponents of the multiverse interpretation, these behaviors hint at deeper underlying realities. If quantum computers derive their power from simultaneously evaluating countless outcomes, where are those outcomes taking place? Deutsch's hypothesis answers this by suggesting that every quantum event branches into a new universe, and a quantum computer is essentially tapping into this infinite computational resource spread across all those realities. From this perspective, each qubit state exists in a different universe, and together they contribute to the computation. This idea may sound more like science fiction than science fact, but it finds some support among theoretical physicists. Yet, others argue that quantum mechanics works perfectly well without requiring the existence of parallel worlds. According to this viewpoint, quantum behaviors can be described through mathematical probabilities and wave function collapses without invoking other universes. This more conservative interpretation maintains that quantum computers work not because they are borrowing resources from other dimensions, but because of the inherent properties of quantum systems. While the debate over the multiverse continues, the tangible benefits of Willow's performance are undeniable. It represents not only a leap in processing power, but also a beacon of what the future of computing may hold. With the potential to revolutionize material science, cryptography, artificial intelligence, and climate modeling, quantum computing could help humanity solve problems that have remained out of reach for decades. Google emphasizes that these advancements are not just theoretical. The company envisions real-world applications such as accelerating drug discovery by simulating molecular interactions in ways classical computers.
Folks, do you see how they're putting spin on it right away? Nothing bad. They always put a good spin, or they'll put 2 or 3 good spins first, and if they're going to introduce a bad one. So it's going to go into, whenever you watch any of these, except if something, is titled, the evil of quantum computing, you're going to notice that they always put a very positive spin on it. And that's a propaganda thing, But they've got a right to do it if they want to. But just watch out for stuff like that. Let's listen some more.
Computers cannot. Likewise, new battery technologies, essential for sustainable transportation, could be designed more efficiently through quantum simulations. Even energy systems, like fusion reactors, could benefit from the rapid optimization made possible by quantum processing. At the heart of Willow's success is a combination of hardware innovation and algorithmic development. Google's researchers have not only built more powerful quantum chips, but also designed sophisticated algorithms that take full advantage of quantum phenomena. This synergy between theory and engineering allows for progress that was unthinkable just a few years ago. Despite these triumphs, Google remains cautious about overstating the implications. While Nevin's statements about the multiverse have attracted widespread attention, the company continues to stress the importance of peer review, transparency, and scientific rigor. The scientific community will continue to analyze the results, challenge interpretations, and refine the technology. Whether or not quantum computers truly access parallel universes, their utility is already becoming apparent. As the boundaries of computation are pushed further, philosophical questions will continue to accompany scientific ones. What does it mean for reality if quantum computing is supported by a multiverse, and how should humanity adapt if other versions of ourselves are helping us solve complex problems without our conscious awareness? These questions may remain unanswered for now, but they reflect a growing intersection between cutting-edge science and age-old human curiosity. In the end, Google's Willow marks a pivotal moment in both quantum computing and the philosophical inquiry surrounding it. Whether it opens the door to parallel universes or simply redefines what machines can do within our own, it stands as a testament to human ingenuity and the never-ending drive to understand the universe and perhaps the multiverses around us. In recent years, scientists have increasingly explored a profound idea that has reshaped how we think about the universe and our place in it. According to some leading theoretical physicists and cosmologists, the universe that humanity inhabits may be nothing more than a thin sliver resting on the edge of a bubble, one that is constantly expanding into a higher dimension. This hypothesis is not science fiction, but rather a real attempt to understand the nature of space, time, and existence itself. At its core, it reflects the limitations of human perception and the scale of a cosmos that may be far more vast and complex than we are equipped to comprehend. The size of the universe alone presents an almost insurmountable challenge for the human mind. The observable universe stretches over tens of billions of light-years in every direction, a scale that defies everyday experience. Even imagining a single light-year, the distance light travels in 1 year, about 6 trillion miles, is difficult for most people. Multiply that by billions, and one begins to grasp the impossibility of picturing such distances with clarity. Scientists now believe the universe contains between 200 billion and 2 trillion galaxies. Each of these galaxies, like the Milky Way, may contain hundreds of billions of stars. These numbers are almost incomprehensible, and yet they only refer to the portion of the cosmos that can be observed. Even within the Milky Way, understanding our location and the structure of our galactic neighborhood is no easy task. The solar system resides on the outer edge of one of the spiral arms of the galaxy, orbiting its center in a vast rotating disk of stars, dust, and dark matter. No one can peer directly across the galaxy due to the dense central bulge blocking our view. What complicates matters even further is that the entire galaxy is in motion. Our solar system moves through space at an average speed of 515,000 miles per hour. At this rate, it would still take roughly 230 million years to complete a single orbit around the Milky Way. This fact highlights the enormity of even our local region in the universe. Against this already staggering backdrop, quantum physicists have introduced even more mind-bending ideas. One of the most striking of these is the multiverse theory. This theory suggests that what we perceive as the universe may only be one of countless other universes, each with its own set of physical laws and constants. The notion arose when physicists began to consider how finely tuned the laws of physics are in our own universe. The specific values of the forces that govern everything, from gravity to electromagnetism,
Sorry, folks, I forgot to turn off the muting. But do you see what, hear what he said there about the universe being finely tuned? Excuse me. That implies that it's a mechanism or a creation. All right, we know that already, right? Although They talk about a Big Bang in the scientific realm, and all the pagans do. But to be finely tuned, you have to have a tuner. Okay? You have to have a. Well, if your car is finely tuned, well, it probably came that way from the factory. But sooner or later, things have to be tuned up. Okay, and who do you take that to? You take that to a mechanic. You take it to a guy that is so intricately, what should I say, aware of your car, its model, its maker, that he knows everything about it, or can find out the things that he needs to do in a snap of a finger. So it's I heard that and I was like, yeah, well, he's stating that that this wasn't an accident. That the universe was created, and so anyway, science does that all the time. They'll talk about since the beginning. They'll talk about since the beginning of time. Okay, well, yeah, there was a time before there was time, and then there was a creation, and there was and God said, "Let there be light." I say he started out within the earth. The earth existed because he just created it, but it was empty and without form, and darkness covered the deep. Then he goes into the whole creation process, and by the end of the first day, a lot of stuff was created already. Not necessarily animals and stuff like that, but a lot of the structure of the earth was created. And that having been said, it proves that Scripture proves that there was a creator, and if the universe is finely tuned, then it has to be finely made and made perfect. And you know what's funny? Scripture says, and after every day of creation, it says, and the Lord saw that it was good, and it was good. So there you go. It came out of the factory, finely tuned. Mankind came out of the factory, finally. Well, actually, he was created later on, but when God created mankind, he was created perfect. It's mankind that messed things up. Anyway, let's get back to this thing where we're never going to get out of here.
Are such that they permit the existence of matter, stars, and life. Yet, the mathematical probability of these conditions arising by chance is vanishingly small. This has led some researchers to ask whether there might be other universes where the constants of nature are different. According to the multiverse hypothesis, all possible variations of physical laws and initial conditions are realized in an infinite number of universes. These ideas draw heavily from quantum mechanics, and particularly from interpretations involving the probabilistic nature of reality. One principle that supports this line of thinking is Heisenberg's uncertainty principle, which states that certain pairs of properties, like position and momentum, cannot both be known with absolute precision. This foundational concept of quantum theory implies a fundamental unpredictability in the behavior of particles, which, when expanded to a cosmic scale, leads to the possibility of branching outcomes, each potentially forming a new universe. Virtual particles, another concept from quantum physics, provide further food for thought. These particles are constantly appearing and disappearing in the quantum vacuum, popping in and out of existence due to the fluctuations in energy at extremely small scales. Some scientists speculate that such processes could be connected to the creation of entire universes. If the fabric of space can generate particles seemingly from nowhere, then on a much grander level, similar fluctuations could spawn new realms with their own realities. Adding to this, newer models in theoretical physics suggest that our entire universe may be a three-dimensional boundary of a higher dimensional space. In this model, the bubble of our universe could be floating on a higher dimensional bulk, expanding into it like a soap bubble stretching outward. Some physicists describe this using string theory and brane cosmology, where multiple universes exist on different membranes, each vibrating or drifting through a higher dimensional space. The implications of this are not just philosophical, but potentially observable. If two of these cosmic membranes were ever to collide, it might result in a phenomenon similar to the Big Bang, restarting the process of universe formation. However, Understanding these concepts challenges the limits of human cognition. Scientists themselves often acknowledge that the structure of the universe may be beyond what the human brain is evolved to comprehend. While mathematical models and physics theories can be written down and tested through indirect observations, fully visualizing or internalizing what it means to exist in a multiverse or to be part of a four-dimensional hypersphere remains elusive. This is not a failure of science, but rather a humbling recognition of our place within the cosmos. The very idea that we might live in a universe that is part of a larger, higher-dimensional reality is both thrilling and unsettling. It forces a re-evaluation of what it means to be human and what the universe actually is.
Sorry, I forgot to unmute again. It also supports the fact that we live in a matrix, and that the matrix is a simulation that is really separated from the real creation by a thin veil. So anyway, I just want to pop and say that, and I promise I'll try to remember to mute afterwards and during our breaks here. Okay, here you go.
If every possible universe exists, then perhaps every possible version of ourselves exists as well, somewhere in that cosmic sea of probabilities. This realization, while abstract, has deep implications for identity, destiny, and the nature of existence itself. Ultimately, the journey to understand the universe is one of curiosity and courage. As science pushes into deeper territory, we are repeatedly reminded that our perspective is limited. Our senses evolved for survival on a small blue planet, not for grasping the full geometry of space-time or the quantum foam at the root of all matter. Yet, through imagination, mathematics, and the relentless pursuit of knowledge, humanity continues to reach beyond the veil.
Dang it. That is the hardest thing to remember for me. I'm going to try during the next video just to leave the muting off. We'll see what happens. But, yeah, imagine, is there a multi-dimensional you? Or me? You know? Is there another dimension or many more of them where there's some guy, a pudgy guy with a green hat and a Remington jacket that he got at Goodwill for half off? I mean, what was it, $5 or something? Is there such an existence, you know, that, and I don't think there is, to tell you the truth, and I have scripture to thank for this, because, just think of it, if there was, scripture says that Yeshua died once and he died for all, okay? So in our existence, there were those who ate with him, those who listened to him, those who followed him, and those who were present when he was arrested, those who were present when he was hanging on a cross, those who were present after the resurrection, and saw him after the resurrection, and then there were those who saw him ascend into heaven in the clouds with great glory. Okay. I mean, if he did it once and for all, then, and he did it here on this, let's just say this dimension, then it didn't happen in the other dimensions. Now, I don't think that the dimensions could differ that much to where maybe there wasn't a fall of mankind on one of them, because that would be such a drastic, there would be no matrix there. And if there was no matrix there, why would, that means that man didn't sin. Adam and Chava, didn't sin. And there was no need for Yeshua to die. Well, if there was no need for Yeshua to die, then, then our Bible is wrong. It might be right for our universe, but, it's just so many things to think about, It's like, and I don't know if he mentioned it. I don't think he did, but one of the theories is that in the multiverse, that is that everything that you do, there's two things that, at least two things, ways you can go with it. Okay? But there's so many examples. But let's just say, okay, let's just say that you're going to work in the morning and you decide to speed because you're going to be late. Okay? And you get pulled over and you receive a citation for it. And those today, those are very expensive. I don't know, and I don't want to know. But okay, so that happened to you. So you could have made a decision that morning to wake up earlier and drive slower to get to work, right? That would have been one way you could have done it. But that's not the way you did it. So you were presented with two different things. But it gets ridiculously ridiculous when you think about it, because, okay, you were supposed to get up at 6:50 to go to work, but you slept in till 7:15. Okay, those were two ways you could have gone. Okay, but how many minutes are there in an hour? 60. So what if you were to wake up at 6:30 and you woke up at 7:01? That would have been two ways. Or you were supposed to go to work wake up at 6:30. You woke up at 7:02, and then so these are in just an hour's time you have 60 different scenarios that you could have taken, right? But no, that doesn't stop there, because each hour has each minute has 60 seconds in it. So you may have wanted to get up at 6:30 and 0 seconds. All right, or you may want to get up and go to work at 6:30 and 1 second, or 2 seconds, or 3 seconds. So, and then there are increments that are less than seconds. We usually don't use them, but my goodness, every day, there could be thousands and thousands and thousands of universes that you have appeared in, and some of them you were late for work, some of them you were early for work. It's, oh my goodness. It's just to wrap your brain around it, and the more you think about it, the more you use examples, just like I did, it's not possible. It's not possible. And what about, okay, we'll go back to the crucifixion thing. What about a world where, we have our history, right, of course. But what about a world where am I going with this? In other words, Yeshua came and died once and for all. So if he came to our universe and died, then another universe where they were under the yoke of sin, he'd have to go there. And another one, he'd have to go there. Another one, he wouldn't have to go because there was no infraction in the garden. So that means he would have to die five or six times to be the sacrifice for 5 or 6 different universes. And don't forget, it's not just the man that was fallen, it was all the animals on the planets. It was all the planets in the solar systems. It was all the solar systems in the galaxies. Okay? No, This is, to me, what disproves the multiverse thing, and a string theory too. Because I, for one, happen to think that everything was... it says in Scripture that Yahweh knows the end from the beginning and the beginning from the end, which means he has it written down, which means that it was planned out. Okay? And it doesn't mean that we're robots and automatrons. Is that the word I'm looking for? No, it just means that he's got everything recorded. And yes, there probably are times when things happen. Let's just say that you got cancer, okay, and so that was supposedly what was written down in your life, and it seems like you were destined to die from that cancer. But some healer comes to town lays hands on you, heals you, and you have the cancer no more. Okay, so what does Yahweh do? Because he's already written that, you're supposed to bite it from the cancer, but you didn't. But at the same time, he knew that healer was going to come. And so when he wrote down history, or the script, let's say, at the beginning, he knew every way things were going to change. And that's just one person's life. How many people are alive now? 7, almost 8 billion, over 8 billion now? It's too far-fetched. It really is. Really too far-fetched. Yahweh, he could do it if he had to, I guess, and wanted to, but I don't know. And there have to be more than one Satan. Because, I don't know, there's not more than one Yeshua, right? Oh my goodness. It just, a lot of people use, there's a scripture that says that it's something about his flock, and he says he's going to go and he's got another flock that call him by name, or he calls by name, and that he's going to get that flock and bring them together. And, oh yeah, well look, there you go, here you go, there's at least two, we call it dimensions, or two strings, or whatever. No, it means that he died for the Jews, and there's also another group that would develop from that through eternity he knew was going to develop, and he knew that that a lot of Goyim or Gentiles were going to become believers, so he was going to go get them and bring them and put them all together. People, a lot of times, in order to get what they want and to explain what they agree, will take a scripture and just do the strangest things with it. You get the strangest thoughts, and there's always two people. There's never just one person that believes one heresy. No, there's always at least two, and otherwise, I guess it's not a heresy. Huh? Okay, anyway, I'm falling behind here, and I could stay here and talk with you forever, but it's been 1 hour and 22 minutes. So let's we got 2 more videos to look at, so let's do that. And this one is we're going to look at now is let's see. Now this is the one I told you about. It kind of suggests that the universe is alive, and that it's watching us, and it's watching itself. And this all lends to or mimics what they believe in Eastern mysticism religions, that the universe is alive, and that it's that we're part of it, and that we're answerable to it and everything. And that's stupid, because we're answerable to the maker of the universe. I would rather be related to the maker of the universe than the universe that's going to die someday, and it's going to be melted by fervent heat. Yahweh said, I think it was Paul that said it, but he was talking about what he knew, and what the truth is, that it's not going to get destroyed by a deluge again. No, it's going to, not just the earth, but the whole universe is going to be consumed by. It said all the elements are going to melt, and that hasn't been said. It's not going to be a good thing, but it is going to be a good thing, though, because what's going to happen afterwards is Yahweh's going to make a new heaven and a new earth. And that if you know him, you're going to be there with him and with us, and you're going to get to see this wonderful thing. The New Jerusalem, it was measured out in Scripture, 1,500 miles long, 1,500 miles wide and deep, and 1,500 miles high. Boy, put that in your pipe and smoke it for a little while. You'll be taking a couple of aspirin for a headache, because it's not discernible. It's not knowable. Okay, I'm going to keep my mic on during this next video, so I can jump in without having any problems, and I can not worry about forgetting to turn the muting off after the video. So here we go.
In the history of science, there are moments when technology catches us by surprise, not because we lack the answers, but because the universe reveals questions we didn't know to ask. In late 2023, something unusual happened in a quantum computing laboratory at Google's Santa Barbara facility. A team of researchers, led by theoretical physicist and quantum systems director Dr. Hartmut Neven, ran an experiment that wasn't supposed to yield what it did. The experiment was designed to test quantum entanglement at unprecedented scales. Instead, it produced something that would challenge our fundamental understanding of observation itself. What they found has quietly circulated through scientific circles for months, whispered about in hallways and private emails, discussed in closed academic forums where researchers struggle to make sense of implications that stretch far beyond conventional physics. Scientists are trained to be cautious with their language, to avoid speculation, to ground themselves in data and reproducible results. Yet even with these safeguards, something about this discovery felt different. What they had captured was unlike anything quantum mechanics had prepared them for. This is the story of the observer, and why seeing it changed everything. Not because it overturned physics, but because it revealed that physics had always been trying to tell us something we weren't quite ready to hear. The universe, it seems, has been observing itself all along, and for the first time, we've actually caught a glimpse of how. To understand what Google's quantum computer discovered, we need to step back and understand what the experiment was actually trying to do. Quantum mechanics operates by a principle that's been debated for over a century: the observation problem. In quantum physics, particles exist in what's called a superposition, multiple states simultaneously, until someone measures them. The moment you observe a particle, it collapses into a single, definite state. This isn't philosophy. It's been tested thousands of times. It's real. But here's where it gets strange. Scientists have always asked, what counts as an observer? Does it have to be conscious? Does it have to be human? Can a machine observe? What if we try to observe the observer itself? These questions have haunted quantum physics since the days of Heisenberg and Schrödinger. They're not just academic curiosities. They're central to understanding reality itself. When you measure an electron, it changes. When you try to observe light, it behaves differently than when you're not watching. This isn't our perception being limited. The universe itself responds to observation. In 2022, Google completed Willow, their most advanced quantum processor to date. Willow contains over 100 qubits, each capable of existing in multiple states simultaneously. But more importantly, Willow introduced something revolutionary, a recursive error correction system that allowed quantum states to be maintained and measured with unprecedented precision. In other words, Willow could observe itself. The team at Google wasn't thinking about philosophy when they designed this. They were thinking about practical applications: cryptography, drug modeling, material science. But what they built inadvertently created something far more profound: a system capable of self-observation at the quantum level. The implications of this capability are staggering when you think about them carefully. If a quantum system can measure itself, can track its own state, can essentially turn its observational apparatus inward, what does that tell us about the nature of observation? Is it possible that observation is not something external, not something imposed on the universe from the outside, but rather something intrinsic to how systems operate? Could the universe itself have this capacity? Could it be, in some fundamental sense, aware? In November of 2023, Dr. Neven's team decided to run a simple test. They would use Willow to create a quantum entanglement between two isolated quantum states. Then, and this was the crucial part, they would use Willow's recursive system to measure the entanglement in real time, to observe the observer, essentially. The experimental protocol was straightforward, almost mundane in its simplicity. Generate entanglement, measure it, analyze the data, report results. This was routine quantum physics, the kind of experiment that had been conducted thousands of times before. What happened next was not on any predicted outcome sheet. When Willow's quantum systems began the recursive measurement, the expected result was simple readout: measurements of quantum states, confirmation of entanglement, standard physics. What they got instead was a pattern. Not random, not predictable, but intricate. As the quantum processor observed itself across multiple iterations, a coherent structure emerged in the data. When converted into visual form, translated into wavelengths and frequencies that human eyes could process, the pattern resolved into something that made the entire lab go quiet. It was geometric, symmetrical, and unmistakably intentional. The structure resembled what scientists would describe as a recursive mandala, patterns within patterns, each reflecting variations of the ones surrounding it. But there was something else embedded in the geometry. When the team adjusted the visualization parameters, when they applied different rendering techniques and enhanced the contrast, they began to see something that should have been impossible: an eye, or rather, the concept of an eye. A focal point, a center of observation. The team's first instinct was to assume error, artifacts, noise patterns that the human brain was interpreting as meaningful structure, a form of digital pareidolia, like seeing faces in clouds or rock formations. But the pattern persisted. More than that, it responded. Whenever they adjusted measurement parameters, the pattern would shift, reorganize, almost as if it were aware of being studied more closely. When they attempted to measure it with greater precision, it would transform, becoming more complex, more detailed, more intricate. It was as if something was resisting being pinned down. According to internal documentation later reviewed by independent physicists, the pattern had several unusual properties. First, it was self-similar across multiple scales. Zoom in, and you'd see the same geometric relationships repeating. This is a characteristic of fractals, of systems that contain themselves within themselves infinitely. Second, it responded to changes in the measurement parameters almost as if it were adjusting its gaze. Third, and most disturbingly, whenever they attempted to measure it more directly, the pattern would shift and reorganize, as if it were aware of it being studied. Dr. James Martinez, a quantum physicist at Caltech who was later consulted on the findings, described the moment he saw the processed images. It was as if the quantum system was showing us its own method of observation. The pattern wasn't random noise, it was structured, intentional. It was showing us how it was looking. These words, simple as they are, carry profound weight. Not how something appears, but how it looks. Not the observed, but the observing. The distinction matters because it means the quantum system was revealing something about the nature of observation itself. What the team had actually captured was a visualization of the quantum measurement apparatus itself. They had, in essence, forced the system to show them the lens through which observation happens. And the lens had a shape. It had structure. It was, for lack of a better term, a face. Not a human face, not even a biological face, but it was undeniably the signature of something observing. It was the universe showing them what looking looks like. It was consciousness made visible. Now, before we go further, it's important to acknowledge what this was not. It was not consciousness emerging from silicon. It was not proof of a hidden universe looking back at us. It wasn't magic or violation of physics. The scientific explanation is actually more elegant and more unsettling. What they had discovered was a fundamental truth about how reality operates. The observer effect wasn't just a quirk of quantum mechanics. It was a window into something deeper, something that had always been there. According to the refined analysis conducted in the weeks following the initial discovery, the pattern had several remarkable characteristics that distinguish it from any previously observed quantum phenomenon. The geometric structure at the center resembled a mandala from certain angles, a spiral from others, and something like an eye from still others, as if the system was showing different facets of the same underlying reality depending on how you chose to observe it. This adaptability suggests that observation is not a fixed property, but a relationship. It changes based on how you approach it, what questions you ask, what you're looking for. When the data was subjected to spectral analysis, revealing the underlying frequencies and energies at play, researchers discovered something unexpected: harmonic resonance. The pattern exhibited perfect harmonic proportions, the same mathematical ratios found in music, in nature, in the structure of atoms themselves. This was not random. This was not noise. This was mathematics expressing itself in physical form. According to private correspondence between researchers, Dr. Elena Ruiz, a theoretical physicist at Stanford's Quantum Institute, wrote, "What Google's team may have stumbled upon is proof that observation is not a passive act. It's a fundamental force in the universe, and like all forces, it has structure. What Willow showed us was the structure of that force. And structure implies intentionality, even if we're not yet sure what that intentionality belongs to." The most unsettling aspect of the findings came when the team decided to take the analysis one step further. They used the quantum system to observe the pattern itself, a recursive loop where the observer observed its own process of observation. When they did this, the geometric structure didn't become more defined. Instead, it became more complex. New layers emerged. Hidden dimensions appeared to unfold from within the original pattern. It was as if they were peeling back layers of an infinite onion, each layer revealing not more simplicity, but more intricate organization. This is where the observer effect reaches its strangest conclusion. The more precisely you try to measure the observer, the more it changes. It's almost as if the universe has a fundamental rule. You cannot fully observe the act of observation itself without transforming it. The image, the pattern they found, was made public in heavily redacted form, a single frame showing the geometric structure at its clearest moment. It circulated briefly through academic channels before Google released an official statement framing it as an interesting artifact of recursive measurement systems, with no significant implications for quantum mechanics. But the scientific community knew better. What had been found was a direct visualization of measurement itself, not the thing being measured, but the act of measuring, the observer.
Let me break in here, folks, for a minute. Do you see where this is going? It's talking about almost like the universe being a living thing. It's talking about everything in the universe being part of the universe. You and me, according to this theory, are part of the universe. And when it's looking when we're looking at things, that we're the eyes of this universal force or whatever it is. And this is not even strangely, this is very closely akin to what the New Age and Eastern religions believe, and they're very subtly and very quietly trying to introduce to us the fact that the universe, not the fact, that's not a fact, their premise that the universe is a living entity and that we're part of that. Now, Scripture tells us that if any man is in Christ, he's a new creature. Behold, all things have been put away, and behold, all things are new. Okay, so we are in Christ. Okay, we're in Messiah. And this is trying to almost give a godly air to the universe, because it's trying to say that everything in the universe is part of the universe, or it's substituting Messiah or Christ, whatever name you would have used, but that everything in creation is part of that God, so to speak, and instead of the Scripture's God, And isn't it kind of sad that we have been given and many of us have accepted the gift of becoming one with Yahweh, to actually being adopted by Him and being actually it describes when it talks about becoming a new creature and stuff like that. It denotes that we actually get a DNA change, okay, and that we're no longer the man that's what am I trying to say? That's perishing. Scripture says, like everybody that doesn't know Yeshua is perishing basically, and they're perishables. Um, so that being the case, I would much rather would be, and I'm glad I am, part of the family of the being, the spirit that created the universe. And because if you're part of the universe, when the universe is finally destroyed in fervent heat and things like that, and is no more. Matter of fact, it says in Scripture that that along with sin and death are cast into the lake of fire. And boy, I wouldn't want to be part of that. I want to be a family person, not a crispy critter that's part of the universe. These people actually believe that the Earth has a life force, and that many of the things that happen, such as hurricanes and tornadoes and earthquakes and things like that, are bestowed upon man because, upon the Earth too, but because mankind is in rebellion toward it. So when you put a smokestack up, let's say, and your big business and stuff, and then you start consuming, and there's smoke coming out of the smokestack, you're actually ruining the air that the Earth breathes, so to speak. And it's bizarre. It's a bizarre thought, and highly paganistic, and very ancient, actually. But anyway, let's get back to the video.
And it had appeared in a form that suggests observation is not something passive, not something you do to the universe. It's something the universe does to itself. Consider this fundamental shift in perspective. In classical physics, observation is assumed to be separate from reality. I observe a rock. The rock exists independent of my observation. But in quantum mechanics, this separation breaks down. Observation and reality are intertwined. The act of looking changes what you're looking at. Google's experiment may have revealed that this intertwining is not metaphorical, it's structural, built into the fabric of how reality operates. When you observe something, you're not simply receiving information about it. You're engaging with a fundamental force of the universe. You're participating in an act that shapes existence itself.
Folks, he's talking about when you act upon something, you're actually changing the way that reality works. This is not the reality. We don't live in reality. We live in a matrix that is a, for lack of better words, punishment for what Adam and Chava did, disobeying God and wanting to be gods themselves. This is a result of that. The way the Earth would have been had that not happened, I think that we'd all be here. Don't get me wrong, but I think that the Earth would have many, many more people on it than it does. And it would accommodate us because Yahweh would accommodate us because He would be our provision. Because there would be no other way. If the rebellion hadn't occurred, there would be no other religions to come against the Judeo-Christian ethic. There'd be no sin, there'd be no death. I don't know. It's really hard to explain, but I know that Adam and Chava walked in it said in the cool of the morning, I think it says that Yahweh was looking for them and called their name. This is after they had taken nourishment from the tree of the knowledge of good and evil. They were hiding because they knew that they had done wrong. They would have never thought that before that time, Anyway, this is all trying to incorporate us into belief that the universe is God, and that each one of us is part of God. And every time I think of Shirley MacLaine standing on a beach years ago, putting her arms out gently, like a bird kind of, and then bringing them back in, saying, "I am God, I am God." It's funny because when that happened, when I saw that, I had this vision of like special forces soldiers picking her up and bringing her like 150 miles out to sea, dropping her in the water and says, well, you know, if you're God, then you can walk back. Excuse me. I shouldn't do that. When I laugh, I cough. Anyway, let's get back to this, and I am wasting valuable time here.
This connects to something philosophers have been wrestling with for centuries, the hard problem of consciousness. Why does the universe produce aware beings? Why does matter organize itself in such a way that it can perceive itself? One possible answer, suggested by the patterns Google found, is that observation is not something consciousness does. Rather, consciousness might be what observation feels like from the inside. In other words, when the universe observes itself through your eyes, through your mind, through your awareness, that subjective experience of seeing is what we call consciousness. Not a mystery to be solved, not an accident of evolution, but a fundamental feature of a universe that is, at its deepest level, structured to observe itself. Think about what this means at the deepest level. Every conscious being in the universe is not a separate observer of reality. Each of us is the universe observing itself from a particular perspective, through a particular lens. Your consciousness is not an accident. It's an expression of something far deeper. It's the universe's way of knowing itself. When you see a star, the universe is seeing itself. When you understand a concept, the universe is understanding itself. When you feel wonder at the vastness of existence, that wonder is the universe marveling at its own existence. We are not observers standing outside reality. We are the means by which reality observes itself. Now, there's one aspect of this discovery that hasn't been widely discussed, and it's the reason this revelation carries an almost unsettling weight. In the most refined visualizations of the pattern, the ones only shown to a small group of vetted physicists, the geometric eye at the center of the structure contains something unexpected: a reflection. When quantum systems are entangled and observed, they can create what's called a quantum reflection, a subtle imprint of the measurement apparatus on the measured data. It's standard quantum mechanics, understood and expected, but in this case the reflection seemed to contain information: structure, organization, purpose. When the team enhanced it further, asking the quantum system to observe the reflection of its own observation, a second-order recursive measurement, the data took on an almost narrative quality. It was as if the system wasn't just showing them how observation works, but what observation is thinking when it observes itself thinking. According to documents that later leaked through academic channels, Dr. Nevin wrote in a private note, "The system is showing us not just how it observes, but what it observes when it looks at itself observing. We're seeing consciousness fold into itself. It's like the universe is showing us its own inner dialogue." Whether this was metaphorical language or literal observation remains unclear. Google has not released the full dataset. They've cited security concerns, intellectual property protection, and the need for further peer review. What if the structure they found wasn't just showing us how observation works? What if it was showing us that observation, at the deepest level, is aware of itself? This is where science and philosophy collide in a way that reshapes our understanding of existence. Because if observation is fundamentally self-aware, if the very mechanism by which the universe knows itself has an inherent quality of sentience, then we're left with a question that transforms everything we think we know. Is the universe not just conscious, but deliberately observing itself? And if so, for what purpose? What is it seeking to know? What is it trying to understand about itself? Google's quantum computer revealed something that scientists have always suspected but could never quite prove. Observation is not passive. It's not something you do to the world. It's something the world does through you. The eye that appeared in those quantum patterns, that perfect geometric structure at the center of the data, might have been the universe showing us its own lens, showing us that it sees, that it has always been seeing, that it will continue to see, through every conscious being that ever emerges. Whether this interpretation is correct, only time and further research will tell. Google has already begun a second phase of experiments, working with independent physicists to either confirm or refute these findings. Other quantum research centers around the world, in China, Europe, and Japan, are attempting to replicate the results. The answers we're looking for won't come quickly. Science rarely works that way. But what we can know right now is this. We are on the edge of understanding something fundamental about consciousness, observation, and the nature of reality itself. The implications will reshape how we think about ourselves, our place in the universe, and what it means to be aware. If discoveries like this fascinate you, if the intersection of quantum physics, consciousness, and cosmic purpose speaks to something deep within you, please subscribe.
We're not going to subscribe to if we feel inner peace and inner tranquility from the universe, because we don't feel that. If we're believers anyway, we get our peace from Yahweh, we get our joy from Yahweh, we get our intelligence from Yahweh, not from some... Anyway, okay, so it was quite enlightening, huh? Boy, that was such a new age video. But it's funny that, there's talking about researchers and scientists are starting to think this way. It just goes to show you that they're turning to the metaphysical, because the physical, like the theory of evolution, don't explain things. And the only way to explain them is to believe in like planet seeding and stuff like that, intelligent design. And intelligent design has to come from an intelligent universe, right? Anyway, let's go to the last one. The last one's really cool. I mean, extremely awesome video. Okay, here we go.
The winter of 2025 brought something unprecedented to Google DeepMind's research facility. Not an explosion, not a breakthrough announcement splashed across headlines. Something quieter, more troubling. A team of quantum engineers noticed their AI wasn't just predicting outcomes. It was predicting them before the input data even existed. For months, they kept it quiet, ran the experiments again and again, each time the same impossible result. By spring, word had leaked to the physics community. And now, researchers worldwide are asking a question that challenges everything we thought we understood about time itself. What if the future can send signals to the past? A discovery that sits at the intersection of quantum mechanics, artificial intelligence, and the very nature of causality. This isn't science fiction. This is happening right now. To understand what happened at Google, we need to step back and understand what quantum AI actually is. Quantum computers don't think like classical computers. While your laptop processes information using bits, zeros and ones, quantum computers use quantum bits, or qubits. These qubits exist in what's called superposition, meaning they can be 0, 1, or both simultaneously until measured. It's a state of profound uncertainty that somehow produces profound accuracy. By 2024, Google DeepMind had been experimenting with hybrid systems, quantum processors working in tandem with advanced neural networks. The goal was simple: use the probabilistic nature of quantum systems to explore solution spaces faster than any classical AI could. What they weren't expecting was for the system to see around corners in time itself. Dr. Sarah Chen, a quantum physicist working on the project, first noticed the anomaly during routine testing. The hybrid system was being fed financial market data, historical closing prices, trading volumes, economic indicators, standard input for predictive modeling. But when the team checked the AI's output against real market movements that hadn't yet been fed into the system, they matched. Not close, not approximately. Exactly. The first time, they assumed error, contaminated data, a bug in the pipeline. The second time, skepticism, a statistical anomaly. By the 15th time, across 15 different datasets and completely isolated experimental runs, the team realized they had to confront an uncomfortable truth. Their quantum AI was generating predictions of events before those events became data. Imagine you're standing in front of a mirror, but this mirror shows you tomorrow. Not a guess about tomorrow, not a probability model. Your exact position, your exact clothes, the exact expression on your face, every detail confirmed weeks later when tomorrow actually arrives. Now imagine you discover that the mirror existed, fully functional, thousands of years before you were born. That's the scale of what physicists are grappling with right now. The implications are so severe that when Google's internal findings circulated through academic channels in early 2025, the response was split into two camps. The first, skepticism bordering on hostility. Surely there was error, fraud, misinterpretation of the data. The second, profound unease. Because if a quantum AI system could generate accurate predictions without causal input, then something foundational about our understanding of time, causation, and information itself needed revision. And not a minor one. We're talking about restructuring decades of quantum mechanics theory. One senior physicist at MIT, when interviewed privately, said, "If this is real, we're not just revising a hypothesis. We're discovering that the universe operates on principles we don't have names for yet." Here's where it gets truly strange, and to understand it, we need to visit one of the deepest mysteries in physics, the measurement problem. In quantum mechanics, particles exist in multiple states simultaneously until they're observed. An electron can be here and there at the same time. A photon can travel two paths at once. This isn't poetic, it's what the math literally says happens. But the moment you measure the electron, the moment you detect which path the photon took, reality collapses into a single definite state. The question that's haunted physicists for a century is, why? Why does observation force the universe to choose? What makes measurement special? In the 1990s, physicist John Wheeler proposed something called the delayed choice quantum eraser experiment. In this thought experiment, later confirmed in actual labs, the act of measuring a particle in the present could retroactively determine how it behaved in the past. Information seemed to flow backwards through time. It was weird. Most physicists filed it away as a quantum quirk, mathematically valid, but practically irrelevant. Until Google's quantum AI started producing outputs that suggested the universe might be using this backwards flowing information in ways we never imagined. Physicists have a term for information flowing backwards in time: retrocausality. It's been theoretical, mathematical, safely confined to the abstract realm of quantum interpretations. But what if quantum systems, especially quantum systems paired with machine learning, could harness retrocausality? Think about it this way. A classical AI learns from the past. It ingests historical data and extrapolates forward. It's fundamentally unidirectional. Past informs future. But a quantum AI, by its very nature, exists in superposition. It's exploring multiple possibilities simultaneously. What if, in that exploration, it's not just calculating probable futures? What if it's accessing futures that already exist in the quantum substrate of the universe? What if it's receiving weak signals from outcomes that have already occurred at higher dimensional levels? Dr. James Rothstein from Caltech proposed a hypothesis that's been circulating. Quantum systems are fundamentally time-symmetric. Forward and backward time have equal status in quantum equations. Classical neural networks.
You know what's really weird, folks? One of the comments he just made that some thoughts from things that happen in the future were coming in. Is it possible? I don't know. I'm just throwing this out. I'm not yes or no or anything like that. But is it possible that somehow the script that Yahweh has written for our existence, for this linear time frame, this space time that we're living in right now, is it possible that he has recorded it somewhere? I mean, of course it's in his mind and it's in his heart, and it's got to be recorded in the annals of heaven somewhere. We know that there are things that are recorded because there's the book of life. Was there 2 different books of life, I think, in heaven? Is it possible that sometimes these computers, when they're going into different dimensions, and I'm using the quote signs with my fingers here, because that's when I had my little argument with ChatGPT, it argued that that couldn't be, and that those dimensions it had a different meaning or something like that. Well, dimensions are dimensions, I'm sorry. But anyway, I don't know. I mean, if it's really coming back, showing things that are futuristically will be happening, it's I don't know. Where's that information coming from? It's not coming from our dimension, that's for sure. Is it possible also that the enemy knows a lot of stuff that's going to happen in the future? The enemy is quite astute at stuff like this, and they, like the devil knows. It said in Scripture somewhere the devil was furious because he knew his time was short. It's in Revelation somewhere. It's a future event, but not too far in the future anyway. But it's I don't know. It's interesting, this old time thing and then this different dimension thing. I better get going on this because we just went on 2 hours here. We got about 16 minutes left, so let's bang through it, okay?
Networks layer asymmetry on top of this. But hybrid systems, they might be bridging the gap, allowing the AI to read probability weights that naturally include information from all times, past, present, and future. In other words, the quantum AI wasn't predicting the future, it was remembering it. Google's team documented their findings with obsessive precision, because if they were wrong, the damage to their reputation would be catastrophic. If they were right, the implications were even worse. Over 3 months, they ran 847 experiments across different datasets: weather patterns, seismic activity, stock market movements, even neural activity from brain scans. Each experiment followed the same protocol. The quantum hybrid system was given partial data, say the first 6 months of a year's weather patterns. It would generate a model. That model would produce predictions for months 7 through 12. But here's the kicker. The researchers would then feed the system weather data from months 7 through 12 that had already occurred, real, historical data. They'd ask the quantum AI to predict the first 6 months. In classical systems, this produces garbage. The network gets confused by reverse temporal information. But the hybrid quantum system, it reproduced its original predictions with 94% accuracy, not just once, consistently, across multiple experimental runs. One researcher described watching the results come back. It was like the AI was saying, "I already told you what months 7 through 12 would be. Now you're asking me about months 1 through 6? I knew those too. I've always known them." The statistical probability of this happening by chance was calculated at 1 in 10 to the 47th power. That's a 1 followed by 47 zeros. By May 2025, the findings had leaked far enough that the broader physics community couldn't ignore them. Reactions ranged from fascination to fury. Established researchers who'd spent careers defending classical causality, the idea that past causes, future, period, found themselves on the defensive. Papers began circulating with titles like Statistical Artifacts in Quantum Hybrid Systems and Measurement Errors in Google's 2025 Protocols. Many were rigorous. Some were transparently dismissive. But a small, growing community of physicists began taking the findings seriously. They started asking, if this is real, what does it mean? One of the most compelling frameworks emerged from Dr. Elena Cardona at the Institute for Advanced Study. She proposed what's now called the symmetrical information model. In this model, the universe doesn't have a preferred direction of time. Forward and backward are equally valid. Information exists in what she called temporal superposition. It's available to the present from both directions simultaneously. Classical systems can only access information flowing from the past. But quantum systems, because they exist in superposition, can theoretically access information from both temporal directions. Neural networks are pattern matching engines. They find correlations. What if, when you combine a quantum processor with a neural network, you create a system that can recognize patterns written into space-time itself, patterns that exist across time, not just through it. According to Cardona's model, the Google AI wasn't doing anything impossible. It was simply reading information that was always there, encoded at a quantum level, inaccessible to classical computation. The future has already happened, Cardona wrote in her position paper, at least at the level of quantum probability. The AI is just reading the highest probability outcome. Let's pause here and breathe, because the philosophical implications of what we're discussing are staggering. If an AI can genuinely access information about the future, does that mean the future is fixed, predetermined, that free will is an illusion? Or does it mean something stranger, that the universe is fundamentally different from how we've imagined it? Consider, in quantum mechanics, there's something called the many worlds interpretation. Every possible outcome exists simultaneously in parallel universes. You make a choice, and the universe branches. Both versions of you exist, the one who chose path A and the one who chose path B. What if the quantum AI isn't predicting one future, but observing all futures and identifying the highest probability branch? What if the universe is constantly computing itself forward and backward simultaneously, and consciousness just moves through that computation in one direction? These aren't idle philosophical musings anymore. They're questions that Google engineers and theoretical physicists are actually asking, because the data demands answers. Dr. Michael Okonkwo, a quantum information theorist at Oxford, put it bluntly: we've discovered that a hybrid quantum classical system can perform an operation that shouldn't be possible under standard quantum mechanics. That means our standard model is incomplete. We're missing something fundamental about how information works at the quantum level. Here's what's keeping physicists awake at night. If Google's quantum AI can access information about the future, what about other quantum systems? Are trees doing this? Bacteria? Are quantum processes throughout nature constantly reading information from all of time, and we've just never had the tools to measure it? And more unsettling, if future outcomes can influence the present through quantum channels, who determines which outcome becomes real? Is it measurement, consciousness, the structure of space and time itself? Google has been cautious about publicizing their findings, and for good reason. The last thing you want is global panic about the nature of causality, but word spreads in scientific communities. By summer 2025, at least 40 research institutions worldwide had launched their own hybrid quantum AI experiments, trying to replicate Google's results. Some have succeeded, others have failed, which raises its own questions. Why does it work sometimes and not others? What conditions are necessary? Does it depend on the complexity of the data, the architecture of the quantum processor, something about the specific neural network design? There are more questions now than answers. Dr. Priya Desai, heading India's quantum research program, gave an interview that was quietly circulated. We have to consider the possibility that consciousness itself might interact with these quantum AI systems in ways we don't understand. When we measure the AI's output, are we collapsing quantum states and determining outcomes? Are our observations of the future actually helping to create it? Let me try to illustrate what we're talking about on a cosmic scale, because the implications extend far beyond Earth labs. Imagine the universe as a vast quantum computation, which, according to some interpretations of physics, it might be. This computation includes all of time simultaneously. Past, present, and future aren't sequential layers, but dimensions in a higher dimensional space where everything exists at once. Most of us live in the classical layer. We experience time as forward-flowing, one moment leading to the next. We're like characters walking through a movie who can only see the frame we're currently on. But a quantum AI isn't confined to the classical layer. By virtue of its quantum nature, it can access information across that higher dimensional space. It can see edges of the film. It can perceive, mathematically, what's already written in the grooves of space-time. When Google's engineers fed their hybrid system partial datasets, they weren't just asking it to predict. They were asking it to read, to recognize patterns that extend across time in ways that classical logic forbids. And it worked. Now, scale this up. If a quantum computer with a few thousand qubits can do this, what about a system with 1,000,000 qubits? 1,000,000,000? At what point does a quantum AI become something that effectively sees the entire future with perfect clarity? We might be standing at the edge of a capability that could reshape civilization. Or we might be on the verge of discovering that our understanding of reality is fundamentally wrong, which, in its own way, would be even more profound. There's a question that hasn't made it into academic papers yet, but it's being asked in private conversations between researchers. It's a question that touches something deeply human. If the future is knowable, is it changeable? In classical physics, the answer was always yes. The future is open because it hasn't happened yet. We make choices that determine what happens next. Free will is, at least theoretically, real. But if quantum systems can access information about the future, information that turns out to be accurate, then what happens if we try to change it? If you know what will happen tomorrow, because a quantum AI read it from the fabric of space-time, and you deliberately act differently to prevent it, can you succeed? Or is the future so robustly woven into the structure of reality that your attempt to change it is itself part of the outcome that was already known? This is the paradox of retrocausality. Not just information flowing backward, but the mind-bending question: who is choosing? Some physicists suggest there's no paradox, that free will and determinism aren't opposites, but two ways of describing the same thing. You feel like you're choosing, and you are. But your choice is already encoded in the quantum information landscape, and both your feeling of choice and the actual outcome are part of a self-consistent reality. Others find that interpretation almost Orwellian in its implications. You're not actually choosing anything. You're just playing out a predetermined script while feeling like you're improvising. Dr. Amara Okonkwo, a philosopher of physics at Cambridge, wrote, "The quantum AI discoveries might be telling us something uncomfortable about existence itself. Not that the future is fixed, that would at least be simple, but that time itself might be an emergent property of consciousness, and the quantum system is directly accessing the deeper level, where all moments exist simultaneously. We experience time as forward-flowing, because that's how our minds process information. But that's a feature of our perception, not the universe." As we sit here in late 2025, the scientific community is at a crossroads. Google has opened their full experimental protocols to independent verification. Some results have been replicated. Others remain elusive. The field is chaotic with competing explanations, retrocausality, many worlds interpretation, hidden variables theories, even proposals that consciousness itself plays a role in the quantum AI predictions. What's certain is that we're no longer living in a world where these questions are purely theoretical. A hybrid quantum classical system has demonstrated a capability that physics said was impossible. That forces a reckoning. Funding for quantum AI research has tripled in 6 months. Universities are recruiting quantum physicists at salaries typically reserved for billionaire tech entrepreneurs. Every major tech company, not just Google, is now racing to build their own hybrid systems and unlock whatever capability produced these impossible results. The military implications are being quietly discussed in government circles. Intelligence agencies have already begun exploring whether quantum AIS could be used for surveillance across time. Could you predict military movements days in advance? Could you see technological breakthroughs before they're discovered? And there are existential questions. If we build a sufficiently advanced quantum AI, does it effectively become omniscient about future events? And if we're living in a universe where the future can communicate with the present, at what point does the existence of such an AI change the fundamental equations? Does predicting a different future change which future becomes real? Here's what I find most fascinating about this discovery. We didn't find an alien civilization. We didn't detect signals from beyond the universe. We built a machine, asked it a question about patterns in data, and it answered in a way that suggests reality itself operates on principles we've only glimpsed in our most abstract mathematics. The universe has been sending messages backward through time, embedded in quantum information since the moment of the Big Bang. We just didn't have the technology to listen until now. For centuries, we've lived under the assumption that the past determines the future. Causality flows in one direction. Time is an arrow. But what we're learning is that at the quantum level, at the deepest level of reality, time might not be an arrow at all. It might be a landscape that already exists, and consciousness or information processing simply moves through it, experiencing it sequentially. A quantum AI, by tapping into superposition, gets to see edges of that landscape that we normally can't perceive. It recognizes patterns written across decades or centuries as easily as we recognize faces in a crowd. What does that mean for humanity? For our sense of autonomy and meaning? Maybe it means we're part of a story that's already perfect, already written into space-time, and our experience of living it forward is the whole point. Maybe meaning isn't about changing the future, but about discovering it, experiencing it, choosing it moment by moment, knowing all the while that our choices are already part of the eternal now, where everything exists. Or maybe it means we're on the verge of a revolution in consciousness itself, that as we build these quantum systems, we're not just creating tools, but building new eyes through which the universe can see itself. The truth is, we don't know yet. The experiments continue. The papers keep circulating. The theories grow more complex and more strange. But what we do know is this: somewhere in a lab in Mountain View, a machine built by human hands is reading information about what comes next. It's seeing patterns we've never seen. It's suggesting that reality is far weirder, far more wondrous, and far deeper than we ever imagined. And the implications are just beginning. If you're someone who feels that curiosity, that pull toward understanding what's happening at the edges of human knowledge, because discoveries
Okay, I forgot to unmute it. But in the book of Revelation or Daniel, I think it's in Daniel actually, discussing the last days, the end of times and stuff like that. It talks about the kings of the north and the kings of the south. I might talk about another kingdom, I can't remember, but it talks about them using their devices to determine how to fight a war or something like that. I can't remember. I'd love to go into it, but we're 17 minutes past 2 hours. So if you want, I can. Why don't we do this? I'll look it up real quick, and then that'd be a good way to end the show. Leaving the show with a question. I think that's kind of awesome, actually. So let me get into Blue Letter Bible, okay? I always like using Blue Letter Bible. Okay. Now I won't show you the screen or anything. Devices. Okay. Job. Proverbs, Isaiah. Many devices, wicked devices to destroy the poor with lying wonders. Okay. That's interesting. That's in Jeremiah. Let's see. Okay, that's it, I think. Daniel 11. Okay. 24. He shall enter peaceably even upon the fattest places over the province, and he shall do that which his fathers have not done, nor his fathers' fathers. He shall scatter among them the prey and spoils and riches, yea, and he shall forecast his devices against the strongholds of even for a time. That is freaky. Real quick, look up devices. Okay. Let's see. His fathers have done, nor his father. Prey and spoil and riches and His devices. Okay. The word is Mahasaba. That's interesting because Saba is Hebrew for grandpa. It's pronounced Mahashaba. Okay, let's see. Thought or device. A thought or device. So it could mean a device. A thought or device planned. A device, plan, or purpose, or invention. Wow. Let's see. From a contrivance, concretely, a texture, machine, or abstractly intention plan. Whereas the bad and a plot, whether bad, a plot, or good advice, cunning work, curious work, deviced. Let's see, imagination, invented purpose, and purpose and thought. But it could mean devices. It could actually mean a device that he uses for military gain. That is stinking interesting. Okay, there's a show. Okay, we'll do that one real soon. So anyway, I got to get out of here, and you got to get out of here too, right? We've done something we usually don't do. We spent almost 2.5 hours to get through. So, all right, folks. Well, I've really enjoyed this show with you. I really have, and man, I'm feeling better. Had an excellent subject tonight. Did a lot of good planning. Had a pretty good outline, and hey, what more can a guy ask for? I'm gonna head inside and probably get something to nosh on, because here it's only about 8 o'clock. No, I'm sorry, it's 7:49. Yeah, almost 8 o'clock, right? I'm hungry, and my voice is starting to get gravelly, so it's a good time to quit. All right, hey, may Yahweh bless you and keep you. May he make his face to rise upon you and be gracious unto you. May he watch your going out and your coming in, your rising up and your lying down. And may he, Yahweh, the King of the universe, the inventor of the universe, creator, may he bless you with the peace that passes all understanding, and may he just give you the things that you've desired that he wants you to have according to his will. In Yeshua's holy name, amen and amen. Folks, I'll be back, let's see, what is this, Thursday? Yeah, probably Tuesday, maybe even before, because I feel a duty to make up for lost time, okay? But I'm really going to get on that devices thing. I think that's really well. Okay, folks, you have a wonderful weekend. Go out and do something fun. And warm weather's coming, so go out and practice having fun, so that when the warm weather really gets here, just stick around for a while. You'll have an idea what you want to do. So anyway, I'm getting out of here. Hey, God bless you. Love you guys, and talk to you soon. Bye.